to show you how to optimize a portfolio using some real world stock data. Now, I've actually done one of these using a two stock portfolio and just some made up data. So here I want to do it with some actual real observations, and I'm interested in using Amazon, Google, Tesla, and Berkshire Hathaway Class A stock. So first you have to get some stock prices, and I got these off of Yahoo Finance, and it's very easy to do. If you go to Yahoo Finance, you type in the ticker symbol, and you can get historical data, and you can choose daily, weekly, or monthly. I chose monthly data here, and I chose 5 years of monthly data. And then you can download it to an Excel spreadsheet, and it'll give you the date. It'll also give you the open price, the high, the low, and the close. And I've used the close price here, or the adjusted close, and I deleted everything else. So once you get this data, you need to calculate the returns. And the way you calculate the returns is by taking the current period divided by the previous period minus 1. And I did that, and then I just copied this down, and I did that for all of the data. So I have the returns for each month for each one of these companies. Now, there are several videos that actually show you how to do this optimization problem, and each one incorporates some neat tricks. Some of them are more confusing than others, so I tried to incorporate the tricks that I think are easiest to follow and make the calculation the simplest for you to do. So after getting all these returns, so one little trick is we're going to reference all of the Amazon returns and all of the Google returns later. So one thing you might want to do is define this. And you do it this way. So I highlight all of these, so you don't have to keep coming back to these. So I'm going to highlight these. And in here you see AMZN. I typed that in. I had already named it. So if you type it in, AMZN, and hit enter, it now knows that when you want AMZN, you want all of these cells. And I did it for Google, Tesla, and Berkshire Hathaway Class A. So here I need the expected returns in order to do the optimization problem. So here I'm just going to take the historical average. So I'm going to say average. Now I could run over there and highlight all of those, or I can type in AMZN and you see it highlights all of those cells. So that makes it a lot easier, makes it a lot faster. And I'm going to do the same thing for Google. And Tesla. And oops, I put that in the wrong cell. So let me just move that up here. Equals average. And Berkshire Hathaway. Okay, so now I've got the expected returns, or the average returns for all four stocks. I'm going to need the variance-covariance matrix. Now, you can calculate each one of these separately. For example, I could calculate the variance for Amazon by using either var.p or var.s and then typing in AMZN, so it uses all this data. The difference between P and S is one's the sample variance and one's the population. Technically, you should use the sample variance because this is a sample, but there's not really much difference. The difference is that in a sample you divide by n minus 1, in a population you divide by n. Now, if it's a really small sample, for example, 3 observations, then dividing by 3 or dividing by 2 is going to change that number quite a bit. But here I have 60 numbers. So whether I divide by 60 or 59 isn't going to make a whole lot of difference. Now, I can do each one of those separately and fill in the table, this variance-covariance matrix, or I can use the function that creates the variance-covariance matrix in Excel, and that's in the data analysis pack. Okay, up here you see data analysis. You also see solver, which we're going to use also as part of this calculation. If you don't see these here, you can install them by hitting File, Options, Add-ins, and down here it says Excel Add-ins. Hit Go, and make sure that the solver and the analysis tool pack are highlighted. So let's click OK there, and they pop up here. So I'm going to click Data Analysis, and I've been using this covariance function here, so I'm going to hit OK. And but they have a bunch of different ones. This is why you may want to install it. It does regression, it does pairwise sampling, and stuff like that. So it does quite a bit of stuff. Okay, so you're going to highlight the cells where you have the return data. I've already done that. And you're going to tell it in what cell you want to put it in. And I happen to have that as N16, so I'll just leave it there. And I'm going to hit OK. And here it gives us this information. So here we have this variance-covariance matrix. So let me just copy in the names. We don't want to look at column 1, column 2. And so let me just copy that. And I'm going to put them up here. See if I can get this right. I'm going to actually delete this where it says column 1, column 2, 3, and 4. And I'm also going to type them in. I'm going to delete these as well. So again, you could have calculated each one of these separately. This calculates the population variance and the population covariance, but I don't think it's going to make much of a difference. All right, now let me say that we have here, I'm going to type in, this is Amazon, this is Google, this is Tesla, and this is Berkshire Hathaway Class A. I'm also going to put in here some weights. And I'm just going to make up some numbers, 25%. So our portfolio has to start with some numbers. So we're going to assume that we have an equal weighted portfolio, 25% in each security. And I'm going to copy these here. So I'm going to say this is equal to this one. Right, and this is going to be equal to this one. Oops, sorry. Enter. And this is going to be equal to this one. And this is going to be equal to this one. Okay, so I've got this. Oops, sorry. Let me do that again. Equals. I moved that before I hit enter. All right, so I've got this thing set up here. So I've got this variance-covariance matrix. Now you notice they don't give you the upper part of the diagonal, the upper part of it, because it's symmetric. Amazon with Google is the same as Google with Amazon. So this number should be the same as this number. So again, we can copy these in here to fill in the rest of the table. This one here, Tesla with Amazon, right, should be, this is Tesla with Amazon, should be equal to Amazon with Tesla. And this is Tesla with Google, and so that should be the same as Google with Tesla. And again, the same thing here with Berkshire Hathaway. Berkshire Hathaway with Amazon should be the same as Amazon with Berkshire. So hopefully I can get all these in here correctly. So equals, let's see, this is Berkshire with Google, so that would be the same as Google with Berkshire. And the final one is Berkshire with Tesla, should be the same as Tesla with Berkshire, right? So we should have some symmetry, right? This number should be the same as this should be the same as this should be the same as this. So it looks okay. So when we're calculating portfolio variance, let me just get rid of that there, we're going to need things like the weights. We're going to need some to calculate expected return, standard deviation. We're going to want to calculate a Sharpe ratio because that's how we're going to maximize or optimize the portfolio. We want to maximize the Sharpe ratio, okay, or the slope of that line. So the sum of the weights is going to be equal to, and this is going to turn out to be a condition for making sure that, you know, we invest 100% of our money in the security. So that adds up to 100%. Okay. How about the expected return of the portfolio? The expected return is going to be the weight in Amazon times Amazon's expected return plus the weight in Google times Google's expected return, etc. Now, there's a function in Excel that will do this for us. It's called sum product. So, sum product, it's going to do the, oops, forgot to put the equal sign in, equals sum product. And we want to do the sum product of the weights times these returns. And we get the portfolio's expected return is 3.3548% per month. Now we need the portfolio standard deviation. Now that's going to be the square root of the variance. Now, some people in their videos had you doing some matrix multiplication, and that's actually kind of confusing, I find. So what you can actually do is figure out the contribution that Amazon provides towards the total portfolio variance and the contribution that Google provides towards the total portfolio variance, and then sum them up. What is that going to be? It's going to be every part of the formula. And some of you may remember the formula is, let's say for a two-stock portfolio, it's, you know, WA squared, so the weight in A squared times the variance of A, plus the weight in B squared times the variance of B, plus 2 times the weight in A times the weight in B times the covariance between A and B. So how can we get that? So everything that has Amazon in it, or everything that has A in it, is what A is contributing. So how can we do that? All right, so let me see if this function works here. So I'm going to say what's in cell Amazon's weight times, and I'm going to go sum product. Let's see, times sum product and I'm going to take the weight here times all of these variances or covariances. Oh, wait a minute. One thing I would actually like to do is to lock these right here, these weights, because I'd like to be able to copy the formula over. So I'd like to lock the columns. So I'm going to put a $sign in front of both of those ends. So it's not going to change the number. And then I'm going to copy it over. And hopefully this is going to work, and I'm going to get some decent numbers. So let's think about why this works. Remember, sum product multiplies the weight times the thing. So in the first case, we get the weight of Amazon times the weight of Amazon. So that's the weight in Amazon squared times the variance of Amazon. So that's the first part of it. The second part is going to be the weight in Amazon times the weight in Google times the covariance between Amazon and Google. Now, we're also going to have, you know, the weight in Google times the weight in Amazon times the covariance between Amazon and Google. So you're really going to get that 2 times WA times WB times the covariance between A and B. So here you have the total, all the contributions from Amazon, Google, Tesla, and Berkshire. And if you sum them up, that's the total portfolio variance. So if we want to have the standard deviation, that's going to be the square root. So let's sum those up. Sum up these, but then raise it to the 0.5 power. And so here we get the portfolio standard deviation. All right. In fact, let me just reformat that and make that a percent, and give it a couple of decimal places. And then we have the Sharpe ratio. What's the Sharpe ratio? The Sharpe ratio is the excess return, which is the expected return minus the risk-free rate. Up here I have a 2% risk-free rate, divided by the standard deviation. So let me put that formula in. I'm going to have expected return minus the risk-free rate divided by the standard deviation. So I get this number for my Sharpe ratio. All right, what do I want to do with this? I want to optimize this. I want to maximize this. Now, you can take advantage, again, of these functions, and the solver function allows you to maximize or minimize some function, okay, subject to different variables. So let's see what we can do here. So what do I want to do? I want to maximize the Sharpe ratio, right? I want to maximize it by changing what? I want to change the weights. So I'm going to tell it what I want to change. I want to change these weights. And I have to have some condition. Let me delete that. Delete this condition. Let me put in the correct condition. And I want this condition to be that the sum of the weights. Oops, I'm sorry. How do I get back here to the objective function? So let me just reset all. Let me just do that again. Okay, so I want to maximize this. Right? It's maximize, subject to changing these weights. Enter. And then I want to put in a constraint. And the constraint is that the sum of these weights, these portfolio weights, has to, and you can have set it less than or equal to, equals, greater than or equals. I want it to equal 100%. Right? And I also have this thing set at make the unconstrained variables, that is, these percentages, non-negative. So I don't want any short selling involved here. And hopefully I've done this correctly. And I hit solve. And it asks me to keep the solver solutions. And let's see what happens. It changes some numbers here. It's actually kind of odd. But it has 19% of Amazon and 81% of Tesla, and actually no Berkshire Hathaway and no Google. I'm not sure why it worked out that way, but we have a bigger Sharpe ratio, and so if I did this correctly, that's what your portfolio should consist of. Okay, 19% of Amazon, 81% of Tesla. So I hope that helps in showing you how to take advantage of some of these functions in Excel to optimize a portfolio.